Section 11.3 is concerned with the factors that affect the solubility of gases and liquids in other liquids. We'd previously talked about how a nonpolar molecule such as oxygen, which is a gas at room temperature, can become dissolved in a liquid such as water. And this is possible due to the dispersion forces that can exist between oxygen molecules and the water molecules. And what is observed is that when you raise the temperature of water, you radically reduce the concentration of O2. So we've seen this little chart here where we were talking about how oxygen solubility is highly dependent upon temperature, and the general result is that as the temperature goes up, the solubility goes down. Now, this is a sort of a well-known result for oxygen, but it actually turns out that the solubility of almost all gases decreases with increasing temperature. So a general result is that the solubility of gases will decrease with increasing temperature. The solubility of gases also decreases with the pressure of the gas surrounding the solvent, and this is described by something called Henry's law. And it says that the concentration of the gas that you can achieve in a liquid is equal to the product of the Henry's law constant for that gas and the pressure of the gas in the external atmosphere. So you probably have heard about this, but if you go up high in the mountains, the pressure of gas will decrease, and as a result, the concentration of gas in your body will also decrease in accordance with Henry's law. And you can kind of like get around this effect by using what we call supplemental oxygen. And so what that does is increases the partial pressure of gas in the surrounding atmosphere, and as a result, you'll increase the concentration of oxygen in your blood. It's kind of actually interesting, if you do spend a long time at high altitude, you'll actually start to make more hemoglobin, which is the protein that carries oxygen around in your body. It's actually got these iron-containing centers in it where the oxygen binds, called heme groups. And you'll actually produce more hemoglobin to be able to kind of counter this effect and take advantage of the lower, or counteract the disadvantage of the low concentration of oxygen that's in the atmosphere. When it comes to looking at solids in liquids, typically what we see is that the solubility of solids will increase with temperature. So here's a classic solid sugar, and you can see that as the temperature goes up, the solubility also goes up. Now, it's not always the case. We've got an example at the bottom here with cerium sulfate, where with increasing temperature, the solubility has actually decreased. But the general result is that most of the time, the solubility of solids typically increases with temperature. So when we're looking at the solubility of liquids in liquids, there's a couple of terms that we want to keep in mind. Liquids that are not soluble in each other are described as being immiscible. So a good example of that would be oil and water. And what happens when we put these liquids in contact with one another is that you'll get the less dense liquid will sit on top of the more dense liquid. Liquids that are soluble in each other are described as being miscible, and when you mix those two guys together, you'll just get a single phase, and a good example of that would be alcohol and water. And if you recall from last week, we said that we can kind of judge as to whether two liquids are likely to be soluble in each other using the like versus like rules. So just a very short section, and if you could, it would be great if you'd looked at those three questions, and we'll be going through the answers to those problems on a Wednesday during the Zoom session.